right. All right. Anyway, that's a simple random sample. Okay. I just had to check something with the slides. Okay, so in every sample, though, there's going to be some variation. So if you decide, let's say, to get a sample of, as I wrote there, 1,000 students, and you decide to, keep forming samples of 1,000 students, there is going to be variation. Some samples might have more science majors. Some samples might have more seniors than freshmen, or the other way around. That's understood, though. That is expected. Now, unless you're getting the same exact sample every time, which you don't want to do, there is going to be some variation. Generally, what people do to avoid that is they increase their sample size, which makes sense. I mean, you would want to do that, also because then you're including more from the population. So naturally, you would expect that the more people you use, the more like the population your sample is going to be. Again, you have to be careful because, the more people in the sample, the more work there is for you. Okay, so now let's get into some other sampling methods. One of them is what we call the stratified sampling. With stratified sampling, actually, it's on the next slide. Let me get to it. Here we go. Stratified sampling. I repeated it on the other slide for some reason, so my mistake. There, you're taking the population and you're breaking it up into subgroups. And from each subgroup, you're taking a sample, random sample. Okay, from each subgroup, you're taking a random sample. Okay, and yeah, you want it proportional to the size of the subgroup. So for instance, you could take the population of college students, as I wrote there, and you could break it up by major. Well, that probably would be a lot of groups, but you could theoretically do that. And then you take a sample from each of those majors. Or I guess if you're, how do I say this? You take New York State and you break it up by sections, let's say. And then what you can do is you could take a sample from each section. That's something else you can do. What people generally do, as I have here, is they break up the population by religion, gender, race, what government party they're affiliated with, like Democrat or Republican. Or not affiliated with a party, that's possible also. So that's one way to form a sample. There's actually, the reason I'm emphasizing taking a sample from each subgroup, because you have this thing called cluster sampling, which is very similar, but you're not taking from each subgroup, you're taking some of those subgroups. That's what cluster sampling is. So with cluster sampling, you would break up the population into subgroups. However, you would choose some of those subgroups randomly and then use everybody in that subgroup, in those subgroups you choose. Geographically, they would do this. So it might have been better with that New York State example to use cluster sampling. Or here you could do it with city blocks, as you can see. I guess each city block then would be what they call a cluster. You would choose some of those blocks at random and work with everyone on those blocks. I know they're very similar, so what I did was I searched the internet and I came across this website here, and they had a really good way of distinguishing between the two. Stratified, it's some from all. So members from every subgroup, whereas with cluster, it's all from some. You're taking everybody from some subgroups. So, I mean, that website I found, I put it here. So I think some of the stuff on that website's a little advanced, but this stuff I thought was really good. I thought it'd be good to bring this up. So again, cluster sampling, there's stratified sampling. There's also Systematic sampling here. Here, that's where you take every nth member population. For instance, you can go through a phone book and take every 10th person, or if somehow you had some other kind of list, you could take every, I don't know, 20th person from the list. It's just another way to form a sample. So, are these good techniques? Honestly, I'm not 100% sure. I know the next two techniques I'm going to show you are really not good. Convenience sampling is something you don't want to do. That's when you choose your sample by selecting whoever or whatever is convenient. So you go by convenience, in other words. Another way of saying that is you're using data that's easy to get. It might be already done or it's easy to get, maybe. I give an example here where, you want to know what people think about raising taxes to build a new school. So you or the city might send someone to go to the senior citizens, center, because there might be easy to talk to those people. The problem is, though, is that this data, as in this example, it could be very biased. I'm not saying it's bad to get, their opinions, but you don't want to get just their opinions. Then that's going to be very biased. It's not representative of the entire population, especially since senior citizens, they may not be raising kids in the school anymore. So convenience sampling you have to be careful with. And there's also volunteer response sampling. That's when the samples, they volunteer, and you allow them to do that. You might get that from like a telemarketer, for instance, where they call up and ask you to complete a survey. You're volunteering for it. Or, if you're reading a website for fun and then, you come across a survey asking you about your opinion on raising taxes. You're volunteering to answer. And why is that bad? Well, because the people that volunteer may have a strong stance. Not everyone is going to volunteer, though. So you're missing out on a lot of the population. In other words, it's going to be biased. It's not going to be representative of the entire population. Well, here's another example. Standing on a corner, and then you interview the first 100 or whatever people that agree to speak with you. So there are some ways to get a sample, some good methods, and some that are not so good. Okay. So I figured it wouldn't hurt to look at some quickly. I mean, some of them I got from the textbook. I figured it still wouldn't hurt to look. For instance, let's say, you're, I guess, an inspector on an assembly line. And every 20th soup can is inspected, for defects, whatever. Well, that would be systematic sampling, right? If you go back to here we go, missed it. Systematic sampling, every nth member of the population. So in this case, we have every 20th member, or in this case, member being soup can. The next one down here, as you can see, with the $100 prize, right? They're writing this is kind of like what I said before. You're writing everyone's name on, well, in this case, on a ticket. You're putting it in a bin, mixing it up, and then someone blindfolded is choosing a winning ticket at random. Well, that's simple random sample. Mostly because everyone there is equally likely to win. The person, I'm guessing, can't feel the tickets to see whose name is longest. So that kind of thing. And here's another one. This is with children. What they're doing is they want to get an opinion from kids, so they're choosing 5 schools at random. And they're sampling, talking to each kid in the school, all from some, right? All from some. What is that? That's cluster sampling. I mean, if they took a sample of kids from every school, that would be some from all. That would be stratified. And this is another example here. Has to do with volunteer response because, people are being asked to vote. They're being asked to participate in a survey. So that's volunteer response.